Hello and welcome to Arduino for Amateurs. This is episode number 24, Dot Matrix Display 2. So we're going to be building on some of the stuff that we did in episode 23 in the previous Dot Matrix Display episode. So if you haven't watched that video yet, you might want to, just to make sure you've got all the context to understand what we're doing here. As always, my name is Matt Gracie. I'm a hacker from Buffalo, New York. I'm a member of the Bidhaven Hackerspace. And what I'm talking about in this video is some text formatting and animation stuff that's built into the library we're using to interact with this dot matrix display. In the previous video, we wired everything up and we got it to display a static string, which is pretty cool. But what we're going to do this time is play around with the capabilities of that library, place the string in different places, do some animation, make what the dot matrix display is displaying look a little more interesting. So if we wanted to use this as an output device for something like a real-time clock or a temperature sensor, some of the sensors that we used earlier in this series, we can make it a little jazzier, a little more interesting to look at, right? As before, we are working with this 8-in-1 display module. What this is 8 8x8 LED matrices. So that's a total of 512 LEDs. Did I do the math right? Yeah, I think I did. So each of these LED modules, they're all sort of daisy chained together, and they're all controlled using a MAX7219 multiplexing controller. Because we have that multiplexing controller, and because all these pieces are wired together, we're able to control all 512 of these LEDs using just 3 wires. 5 really, if you count power and ground. So power, ground, and 3 SPI wires. SPI is Serial Peripheral Interface. That is the basic serial protocol that we're using to control this device. SPI is a controller minion protocol, so the Arduino acts as the controller for everything on the SPI bus. It reaches out, it issues commands to the different modules. In this case, we've got 8 of them. And that's what coordinates everything that happens with our dot matrix display. And again, if you want more details on that, I go into it a little deeper in the previous video. On the Arduino side of things, we've got everything wired to our SPI pins here. So digital pin 13 is our serial clock. Digital pin 12 is our peripheral output, which we don't really need here. We're not reading any data from the dot matrix display over SPI. We're simply writing to it, so 12 isn't connected to anything. Digital pin 11 is our peripheral input, so that one is wired up. That's how we're sending commands to the dot matrix display. And then digital pin 10 is our SS or CS chip select. That is what signals the destination for the signal that's coming from the controller, right? So matrix 1 through 8 or 0 through 7, I'm not sure how they're addressed internally, is selected here, and then the input is sent through here. We're using these particular pins because these, as part of the Arduino platform, have hardware acceleration. They're able to do some offloading. You can technically run SPI signal from any pin on the Arduino that you want to, but these ones do it with a minimum of processor overhead, so that's really kind of the recommended way to do it. This is the GitHub page for the Parola library. So Parola is the text formatting library that rides on top of the MAX7219 library. We have to include both of them in our Arduino code. And I'm bringing this to your attention because their GitHub is very, very well documented. It's not just the code for the library, but there's also really good documentation, excellent code examples. We can see that in the next slide here. All of these are Arduino sketches that have example code that you can go in and dig through and learn how the stuff works. There's some videos. There's a lot of really good stuff here. It's probably just generally a good rule of thumb if you're playing with a new component or a new library. Go to the author's GitHub, go to their website, look for documentation. A lot of this stuff is very well documented, and there's plenty of example code and stuff to teach you from. I am not an especially strong software developer. I have many computer science professors in the past who will happily testify to that fact. My code is workmanlike at best, but I'm pretty good at taking example code and tweaking it around and making it do stuff. And that's an approach that works really well with these microcontrollers. All right. Then this is some animation stuff. We'll get to this in just a minute. Now, flipping over to our Arduino IDE, right? This is the code that we put in there last week. So let's go ahead and upload that, make sure everything is working properly. All right. So it's flashing, it lights up, and there we go. We can see our display says Arduino. Right, so looking at the code, let me turn off this bottom panel here. We see we include the Parola library, that's the text processing library. We include the Max 7200 library, that's what deals with that multiplexer chip. We include our serial peripheral interface library that handles the SPI encoding. We define our hardware type. We're using a Max 72XX multiplexer and an FC16 hardware platform. There are other platforms available. This is the one that happens to match this particular display. We define our maximum devices as 8 because we have 8 of these matrices. That's how many it needs to be able to talk to. And we define our CS pin as pin 10. Once again, that is the hardware SPI interface for SS or CS, right? The original standard called it slave select. Now it's called chip select, but it's the same thing. It's all on pin 10. Then we create a new instance of this MD Parola class. We call it MyDisplay, and we instantiate it with the hardware type, which is the FC16HW, CS pin, which is 10, and max devices, which is 8. So we're telling it, I want a new SPI device. It's one of these dot matrix displays. There's 8 of these matrices. This is what type it is. This is the chip select pin, right? Then we get into our setup. We initialize the object with begin. We set the intensity. As you can see, the intensity here is at 1. And that's still pretty bright. It can go all the way up to 15. Then we clear the display. Now we go into our loop. First, we set the text alignment, and this is something that we're going to play around with a little bit shortly. We set that to PA left, meaning we are left justifying the text. We're starting at the left-hand side of the leftmost matrix, and we see that here. This A is right up against the side. Then we print Arduino bang, right, which is what we're seeing on the display here. Then we delay for 2 seconds. Then we clear the display. Then we delay for 2 seconds. Then we go back up to the beginning. So this verifies for us that the display is wired up, that everything is connected properly, which honestly is more of a pain than it seems like. These connectors are a little bit finicky because they're not soldered in place. That might be my next adventure. I'll take this over to the Hackerspace and solder it together so I don't have to jiggle the wires around until it works. But we know that everything is put together and everything seems to be functioning properly, right? So we'll close this, and then we can move on to our next piece of code. So our next test, I took that routine, you'll see here it all looks the same, and I scaled it out. And once again, I forgot to mention this before, but some of this code is based on sample code from lastminuteengineers.com. They've got a great page on Max 7219 integration, so check that out if you have questions. Our new one, all of this is the same. We're including the libraries. We're defining the stuff for our setup. Then we are setting a loop counter. We set the loop counter to 0. The loop counter is exactly what it sounds like. It's going to count how many times we run through the loop function. We create our new instance. We call it MyDisplay. Setup is exactly the same. We begin. We set the intensity. In this case, we set it to 0. We clear the display. And then we go into the loop. And you see our loop is a little bit longer than the old one. So first we set our text alignment left, and then we print left so we can see what left justified text looks like. Then we set the text alignment to right, we print right, do the same thing. What does it look like when it's right justified? Then we do the same thing with center, and then every other time through the loop we're going to set invert. And when I first found this function, I thought that set invert would flip the text upside down, but I was incorrect. So we'll see what that does in just a moment. I'll see how it shows up on the document camera. And then at the bottom of the loop, we increment loop counter, and then we go back up to the beginning. So what this means is every time we pass through this, loop counter will be mod 2 divided. So that means if it is an even number or 0, loop counter mod 2 will be 0, and it will turn on invert. If loop counter mod 2 is not equal to 0, that is, if it's equal to 1, if it's an odd number, it will set invert to false. Okay? So it's going to do left, right, center, invert, left, right, center, uninvert, and so on. All right, so let's compile this, and we'll send it out. And you can see the document camera down here what exactly it's going to look like. Okay? So there's left, there's right, there's center, and now it should invert. Okay, the whole thing lights up left, so it's doing dark letters on a light background. Right, center. Okay, so we've learned some simple commands. We can align text to the left, to the right, to the center. We can also do light on dark or dark on light by using that set invert characteristic. So that's pretty cool. Right? So if we want to use this to actually display something, we have a little bit of option in how we align text. Now, what we can do next is start looking into some animation functions. So in addition to just static text display, if we go here, this is dot matrix scroller, and as always, if you need copies of this code, let me know. I'm happy to post it on GitHub or send it to you. This will, instead of doing static display, will scroll the display. So up here we include the same 3 libraries, right? We do the same hardware type definition, same max devices, same CS pin. We initialize in the same way. We instantiate this MD Parola object. We call it my display. And then what we're going to do here is we're going to call a begin. We're going to call a set intensity. We'll set it to 0. We clear the display, and then we use display scroll, right? So what this is going to do is it's going to take these 4 parameters. It's going to scroll bit haven. It's going to start by centering it. It's going to scroll it to the left, and it's going to be 150 milliseconds in between scroll motions. So it's going to scroll it to the left, and it's going to pause for 150 milliseconds each time. We set the scroll spacing here, and what this does is it sets the distance between the end of the string and the beginning of the next string. Right, so we have sort of a continuous loop of the same string. It's going to do it 4 spaces away. So this is all in setup. And then what the loop does is it basically says if animate is still running, it's going to animate all the zones using the currently specified text and animation parameters. So we set all that here in setup, and then this just continues to animate and continues to animate, right? It's essentially an infinite loop that just says run the next step in the animation, right? So let's upload this and we'll see what it looks like. Okay. So there we go. We see BitHaven scrolling across the bottom there. And then we give it 4 spaces, and then we see BitHaven again, right? So it's just giving us kind of a scrolling marquee of the same string over and over again. And I don't know if you can tell on the document camera, but there's a little bit of a hitch when it gets to the middle. That's when the animation restarts. So it just keeps scrolling the same animation over and over and over again. Now, that code page that I showed you earlier, this is the different animations that are available. And so right here, we've got our scroll up left. We've got grow up, grow down, mesh, fade, all sorts of stuff. If we want to, we can change this animation pretty easily. We can just pick a different one off of the list. So let's try scroll down instead of scroll left. All right, we'll go back here, change this. We'll change this from scroll left to scroll down. Upload again. And now we see it scrolling from the top down instead of side to side. Right? If we want to change it again, let's pick another one off the list here. Let's try PA random. That looks interesting. I'm not sure what that is. Got random in the name. It's got to be good. Oh, it just does sort of a random dots until the string appears. That's neat. And then once it's all there, the dots disappear. So again, this is all in the Parola documentation. All of this stuff is listed under, I can't remember exactly where, like text effects or something like that. Yeah, text effect _T. So this is just like a matrix of included animation techniques. You can also make your own, and there's documentation for that as well, but that's a little bit beyond me and beyond the scope of this video. But suffice it to say, there's a lot of cool animation that you can do here. You can scroll the text any direction you want. You can make it appear, disappear, wipe, fade, slice, whatever. So that's pretty neat. Let's do one last one. We'll do PA opening cursor. That looks interesting. Oh, very cool. Kind of an opening curtains kind of thing, right? Starts with the cursor and then opens from the middle out to the sides and back. Very neat. So a lot of cool built-in animations that we can do with this dot matrix. One last thing I want to mention. Obviously, if you want to have multiple animations, you don't want to have to be back here updating the code every single time like I have been. So let me flip over to one last sketch. And I got this from makerguides.com. They have another excellent Mac 7219 tutorial. It's got some good code in it. So you'll notice the syntax looks a little bit different here. It's just different style because I took it from a different site. We include the same libraries. We include the hardware type, Max devices, CS pen, do all that stuff. In this case, we're instantiating the object, the MD Parola object. We're calling it DISP, D-I-S-P, for display. And then I'll start at the bottom here and then bounce back up. So for our setup, we begin, we set the intensity, we clear, and then we run this switch animation function, which I'll get to in a moment. So we call switch animation 0. In our loop, we have a static integer. And what static means in this case is that the integer is not blanked out and reinitialized every time the loop goes through. It's maintained across loops. So we have an animation ID of 0. And then we have something that's sort of like that previous infinite loop that we saw in the other scroller. But the difference is, instead of just doing the run animate until it's done and then reset, it's run animated until it's done, then reset, then call switch animation. Okay? So what does that mean altogether? Well, what we're doing is we're saying if animation ID is 0, that's what this case statement does. If animation ID is 0, then we're going to use these parameters for display text. And I know the other one used display scroll. They both work. They're just slightly different. So if we want, we can display text left. That will start it in the center, scroll it left. If animation ID is 1, that's what this case 1 does, display text right and scroll it to the right. So what this does is it allows us to stack the animations, right? First we're going to run animate to the left, then we're going to run animate to the right. And we can use this as a building block for what we want to do. Say we've got a message, and then we want to show a variable, like what time it is, right, from one of those real-time clock modules. We could pretty easily do that using a function like this. So let's hit upload here. We are compiling. Okay, and you can see left is scrolling to the left. And then right is scrolling in to the right. Okay, so it does exactly what the code suggests. It scrolls in one direction, then calls the next animation ID, scrolls in the other direction, then calls the next animation ID, scrolls the first direction, and so on. We've just sort of modified that infinite loop that was in the other scrolling code and put in this switch animation function. If you wanted to add more animation, right, if you wanted to have 3 different cases instead of just 2, you would just add case 2, the animation that you want, and then change this so instead of doing animation ID mod 2, you do animation ID mod 3, because there's 3 to choose from. And then it would do case 0, case 1, case 2, case 0, case 1, case 2, and so on. So that lets us sort of stack these animations so we can set them up however we want. I imagine that it's also possible to do it more interactively, right? We could tie it to something like a button or a switch or a noise detector. Any of the other sensors and circuits that we've seen so far. We could have a photo detector, right? Read the ambient light level and print that out here. We could connect it to a temperature sensor or real-time clock. We can basically use this as a display for anything else that we build or program in our Arduino environment. So pretty cool, flexible tool. And with this Parola library, it's really easy to do animation in sort of an eye-catching way and integrate it into the project. All right. That is all that I have for today. I hope you found that useful, and I'll see you in the next video.